Before wrapping up this section on polynomials and quadratics particularly, I would like to emphasize the place value one more time about the polynomials and how as you go from one column to another, you're actually exponentially bumping up another degree. So we have degrees in our equations and we have degrees in the polynomials that make our graphs undulate or or perhaps just do a straight line if it's synthetic linear. Division is used for finding the zero roots in some special cases. It is occasionally on the ACT and SAT. So I want to talk to you more about how you set it up in the way of place value, figuring the place value of the polynomial as a whole, more than this is something that's really critical that you understand for the algebra, although it is taught in your Algebra 2 classes and used in higher math. So let me explain to you that when we have a polynomial, we have place value, and each place value has to be represented. Each of the place values is represented. I have a cubed, a squared, to the first power, and to the 0 power here for our x. What we're trying to do is wipe out this very first term in each case. With an x, I have to have 2 more x's because this is a cubed. So now I'm going to be placing my answer in the squared column because I need 2 more x's for this term to wipe out. And I also need the coefficient of a 3. So it looks like this: 3x squared. When I do the multiplication, you'll understand why I chose a 3. So 3 times a negative 5, 3x squared times a negative 5 gives a negative 15x squared. 3x squared times x is a 3x cubed. Now this matches perfectly. I can now subtract. And when the subtraction step happens, these signs are all changed because we're subtracting. So this positive becomes a negative. That's the only way I'm going to get to wipe that out if this had different signs. And this one changes to a positive. Now I'm ready to combine my terms. This cancels out. That's exactly what we were trying to do, get that first term out of the way. Now I'm moving on and combining through my rules for positive and negative. The signs are different, so I know I need to subtract the numbers. That would give me a 7, and that would be a negative 7 because it takes the sign of the higher numeral. And I'm just going to copy down my label, which is x squared. That piece is finished. I can now bring down my next number, minus 5x. Now I'm going to try to wipe out the negative 7x squared. I'm looking only at my first term here, the x. In order to get negative 7x gone, I need to have a negative 7x. I have 2 x's here. That will give me the squared. And the negative 7 is going to match this perfectly. So that's my next answer, partial answer. It's an x term, just a single x, and I've put it into this single x column, as you can see. Now I'll do my multiplication. A negative times a negative gives a positive. Positive 35x. Negative 7x times x is a negative 7x squared. This is what I want to check. It matches perfectly. I'm ready to subtract. When the subtraction happens, the signs must change. So this one becomes a positive, and this one becomes a negative. Now, I can easily eliminate this first term. and combine what I have in the second, following the rules for positive and negative. Two negatives, when the signs are the same, you add the numbers. So I'm going to add the numbers, use my symbol, my sign of the column. This is the label of the column. And I'm going to copy the sign of the larger numeral, which is negative. Bring down my next number. Now we're trying to eliminate the negative 40x. That's the next value that has to go. It's always the first term in each of the steps. So x and x, I already have an x here, so that's going to wipe out just by being. I need to get rid of this 40. So I'm going to have a negative 40 here. And that matches perfectly. It's in the right column. It's in the plain number column. It's x to the 0 power. Now I'll do the multiplication. Negative 40 times a negative 5 gives a positive. Negative times a negative. The signs are the same. It's positive. 200. Negative 40 times x is a negative 40x. The first term matches perfectly. I'm ready to subtract. When you subtract this polynomial, you have to change the signs. So this becomes a positive, and this one becomes a negative. This eliminates. This eliminates. So we have no remainder. Sometimes there's a remainder. And the answer to this synthetic division is 3x squared minus 7x minus 40. That would be how you would get the polynomial term when multiplied by this binomial term would give you this polynomial back. Synthetic division.